Okay, welcome everybody. My name's Tom Lynch. I'm an amateur astronomer, and I live in Lynbrook on Long Island. I'm a member of the Amateur Observer Society of New York, which is a Nassau County astronomy club. I have several Facebook pages, one being Library Telescope, then Sidewalk Astronomy in Lynbrook, and Long Island Space and Astronomy. So they're kind of about what they sound like, and I talk about astronomical things, and I do sidewalk astronomy, which is me bringing my telescope out to a public place and showing people things in the sky. Haven't been able to do that for quite a while now, so I'm anxious to get started with that again at some point. Okay, so tonight we're going to talk about the Library Telescope program and how to use the telescope. I'm planning on talking for about 15 to 20 minutes, and then after that we can have as many questions as you want. We can go on indefinitely with questions. Okay, I'm going to try to go pretty quickly through this, but it would be nice to do this in person. I typically do it in person with other libraries, but because of the pandemic, we can't. So this is the next best thing that we can do. And maybe once things get settled down, I'll come to the library and do it in person. Because it's great to talk about it, explain how it's working, but it's much better to do that and then have you actually work with the telescope and go through it. So my experience has been, I can teach a 10-year-old, a motivated 10-year-old, to use the telescope in 10 minutes, okay? And to be pretty decent at it too. Doesn't take long, it's a very simple telescope, very easy to use. Okay. Oops. There we go. Okay, so here's the concept. The library buys a telescope and then loans it out to patrons, much like a book. So we're making this one single telescope available to lots and lots of people. I mean, it's really a great idea. And the telescope that was picked is the Orion 4.5-inch Starblast reflector. And I'll explain what all that means in a little bit. And it has some modifications on from what the manufacturer did. And part of that is to make it easier to use, make it more difficult to break or lose things. So it's sort of self-contained. It's very easy, very portable. It's a very small telescope. When you use it, you do need to put it on a surface. So maybe a small table, a picnic table, something along those lines. The manufacturer says you can do it on the floor. Sit on the floor with it. That might work for kids, but I don't think it wouldn't work very well for me. So you really do need a table to be able to put it on. So if you're putting it in your backyard, maybe you've got a picnic table back there or something that you can use. Okay, so this program started in 2008. The New Hampshire Astronomical Society put together the idea, and the modifications that were made were thought up by Mark Stobridge, who we now affectionately call the father of the library telescope. To my knowledge, there's a little over 500 libraries with library telescopes in 44 states across the US. So there's quite a few of them out there, and I'll bet there's a lot that I don't know about. There is a website, librarytelescope.org, that keeps track of all this, and we encourage people to register their library telescopes. And anybody can do that, the library, the patron, whoever. We just want to get a number out there, and I suspect there's a lot more out there. I'm currently working with 9 libraries in Nassau County, so we're moving along here and hopefully more in the future. Okay, so generally when somebody thinks of a telescope, they think of a refractor. So it's the one on the left. It's a long tube, you look through the end of it, and you get a bigger view of something far away. Okay, and this one is on a tripod. Now the one on the right is a reflector. So a reflector is a little bit different. The light goes in at the top, goes down to a mirror at the bottom of the tube, reflects back to another mirror, and up to the eyepiece up at the top. So light comes in here, goes down here, bounces off a mirror here, focuses on a spot right about here, and that bumps it up into the light into the eyepiece. Okay, so that's there are other types of telescopes, but they're sort of mixtures of these two. So again, the refractor, the light comes in, there's a lens here that's machined on 2 sides that bends the light so that and this one has another, different from what I showed in the other one. It bounces it off to an eyepiece here, and that's fine. It's just what's key here is this lens right here that is machined on both sides to bend the light exactly the right way to get it to come up into form an image over here. The reflector, the light comes in, bounces off a mirror, which is only machined on one side. It can be very thick. You'll notice this refractor lens is very thin, and it bounces the light up to another mirror here that bounces it up into the eyepiece. Now, the advantage of a reflector is it's only machined on one side. It's machined on a bigger piece of glass, so less likely to break than the refractor, which is machined on both sides. The bigger that lens gets, the more fragile it is and the more expensive it is to manufacture. So these reflectors are sometimes called light buckets. So the more light you bring into a telescope, the better your image is going to be. Okay, so a refractor is great, but you can only get it so big before it gets too expensive for anybody to do it. Whereas the reflector, I know guys who actually own 24-inch reflectors. So this telescope is 4.5. It's not they go as high as that. My personal telescope is a 12-inch reflector. Okay, so on the right, this is what the Star Blast looks like after you assemble it out of the box. And over here on the left is with the modifications that we've made to it. So some of the things that we do. Now remember, we're trying to make it easy to use and more difficult to have problems with. So there's a cap that goes across, and you can see it over here on the top of the tube. It covers that. And there's another cap over here that goes over the eyepiece. Okay, so you want to keep those on all the time unless you're using it, because you'll get dust to get in there and nothing good's going to happen by having those not on. But when you're using it, you take it off, and they're attached by either string or rope or wire, and you put it down at the bottom over here, and you have it there. So you can't lose it. It's not like you're going to be doing this in relative darkness, so it's easy to put it down and forget it and lose it. So this way you'll be dragging it around with you, even if you do forget about it. Okay, the next piece I want to talk about is the finder scope. So that's this piece right here. Okay, so the finder scope is designed to give you a very wide field of view, so you can point the telescope at what you want to see. Okay, now you would think pointing a telescope at something as big as the moon, right, would be easy. It's not. Because if you're looking through the telescope, you're looking through this eyepiece here, it's very difficult to get it aimed on what you want. But a viewfinder has a much wider field of view so that you can see it much easier. So the way this one works is, this is another picture of it over here. And there's a little knob here. You see those two white dots. You turn that, this is a wheel. You turn that turns it on. There's a very distinct click when you do that, so you know that it's on. And it creates a red dot that gets shined into this viewfinder here. If you can see this, right, there's a red dot there. So if it's lined up correctly, when you look through this viewfinder, and you've got a very wide field of view, about 5 degrees or so, and you can put that on what you want to see. Now you look in the telescope, you'll be pointed exactly at that. If somebody messes with these other wheels over here, there's one here and another one here, that adjusts the alignment. If you turn those, you're going to bring it out of alignment. So I spent a lot of time realigning telescopes, and unfortunately it's necessary because people keep touching them. And I can understand you're not sure which wheel to turn, but it is something that if you leave that part alone, it'll stay lined up and it works very well. So in order to use the viewfinder, you come back here and you look through it from the back, and you look, so you'd be looking right through there, right? And you would see whatever you want it to be on, you put it on that, and then you go in and you look through the eyepiece, which is the next. Now, the telescope comes with, I think it's an 8 and a 20 millimeter eyepiece. And what you have to do is you can take them out and put them back in, and that's the way it's designed. But again, we want to make this easy to use. We want to make it hard to lose things. So what we did was the library bought a zoom eyepiece, which then is glued into or put in with screws that you can't undo. So it's permanently in there. You don't take it off. And the zoom eyepiece works much like a camera zoom lens. You turn it. This is the turning. You hold it there and turn it, and you go from 8 millimeters to 24 millimeters. 24 millimeters is the least magnification. 8 millimeters is the most. I know it's backwards from what you might think, but 24 is where you always start, because you're going to have the biggest field of view. You'll be able to find what you're looking for. This is the zoom eyepiece right here, and it's connected to the focuser, which is here, which I'll talk about in a second. So you have this arrow here, and you adjust this by turning from here. You turn that, and it gets from 24 to 8. But always start with 24, because the more you magnify, the harder it is to find what you're looking for, and the less clear it's going to be. Everybody thinks magnification is a big thing. Sharpness is the biggest thing. You want to have a very sharp image. So start with 24. If you want to zoom in, do it slowly. If you go right to 8, you'll probably lose the object, because you'll be looking at a much, much smaller piece of the sky. So you do it very slowly. Okay, this next is focusing. So this is right here. This is the focuser, and here it is in a bigger shot. There's 2 wheels here. They move in unison, so you turn one, the other turns. And what you do here is you focus the view that you're going to get through the eyepiece. So if everybody had 20/20 vision, it would be the same for everybody, but everybody doesn't. So when you look through it, and it's a very clear image that you're seeing, somebody else could come along and look, and it's not clear, because they have better or worse vision. So they may have to adjust the focuser. So you can turn this, and it brings the focusing tube in or out. This is the eyepiece attached to the focusing tube. So you have that ability to adjust it. If you wear glasses, you're usually better off keeping your glasses on when you look through. If you take them off, you're going to have to adjust it a lot more, so it adjusts to your eyes. Okay, we also have a moon filter, which is sort of a misnomer here, but it's a very low-tech answer to a problem. If you look at the full moon can be very bright. So you're looking through the eyepiece, and you're looking at this full moon with one eye. The other eye is in relative darkness. Once you pull yourself away, one eye is set for very bright. The other one is set for not very bright at all. It can be disorienting. So, and this can happen around the full moon. A quarter moon, it's not an issue. It's usually the full moon, or any 3 or 4 days on either side of the full moon, and because that's just very, very bright. So what I do in my telescope, you buy a moon filter, and you screw the moon filter into the bottom of the eyepiece, and it just darkens the image a bit. As I told you, we put the zoom eyepiece in so you can't take it out. So we came up with this other idea, or Mark Stobridge came up with this other idea, that you take the cover. So this is the tube cover, right? Cut a hole in it and put a cover in there. This is a desk grommet. So we put that in there, and you can leave that on when you're not using it, and then you're putting it away. If you have a full moon, you take this piece out, and you use this. You look at this, so you've decreased the amount of light coming into the telescope, so it darkens the image. It's not so bright. Now, unfortunately, it also minimizes the amount of light going in, so you don't get as good of an image, but it'll still be pretty good. And also, let me say at this point that looking at the full moon is really not the best time to look at the moon. When you look at the moon, at the full moon, there's direct sunlight going to the moon, so there's very few shadows. When you're looking at it at first quarter, third quarter, when it's waxing, getting bigger, or waning, getting smaller, there's a lot of shadows, and you can really get a sense of the depth. You can see the mountains and the shadows created by the mountains. That can be very interesting. You can see shadows in craters. There's all kinds of sense of depth that you'll get at these other times, which you don't get at the full moon. On the other hand, at the full moon, you do see Tycho has tremendous rays coming out of it. And these are material that was blown out of the crater when a meteor hit it and just splashed that across the whole moon. So, there's good things about the full moon, but a lot of the more interesting things you're going to see off the full moon. Okay, we put 3 decals on the telescope. The one on top is do not look at the sun. Okay, you put this on the sun, you look through it, you're going to damage your eye. And I'm not talking like a little bit. I mean, you will burn a piece of your retina. So you don't want to do that. Okay, never look at the sun with this telescope. It does not have a solar filter. If it had a solar filter, you could probably do it, but it doesn't come with it, and I wouldn't recommend you doing it at all. I often tell people, don't even bring the telescope outside until the sun is over the horizon. It's down. You don't want somebody accidentally looking at the sun. This here tells you what the magnification is. So if you're at a 24, remember 24 millimeters is the least magnification, it's a 19 times magnification. And then you go down all the way down to 56 at 8. Aren't too many things you're going to be able to look at 56. Maybe some of the moon, some craters on the moon. Other than that, you're going to lose clarity very, very quickly. Over here, this is a QR code. You take your smartphone and point it at this. It'll bring in the website, librarytelescope.org, and there is a wealth of information about the Library Telescope program in this website. Okay, when you're moving the telescope, I call it the football move. On the left there, you put the telescope right into the fold of your arm, of your elbow, and you pull it towards you. Okay, you only need one hand to do this because you've got it under the barrel, right? So there's no way it's going to fall, and you bring it into yourself. It's not going anywhere. And then you have another arm free to open doors, open car doors, whatever, and move around. On the right-hand side, this is how you put it in a car. You put the vertical piece, this piece here, to the back to the seat, and you put the lap belt across there, and then the shoulder belt goes across the tube. The tube should be pointed upward like this, so it's got it in a solid hold. Okay, now this may not work in an accident, but in normal traffic, this will keep it from being damaged. You don't want to put it in, just put it on the back seat or put it in the trunk, because it'll move around, and some of the things on it are plastic. They can break, other things can bend. So this is definitely the way to do it. Okay, I'm going to run through the whole thing again, kind of real quick. And so you've got the library telescope, and you've got it outside on a table, and you want to look at something. You remove the cap in the eyepiece, right? You take this is the cover for the tube, and this is the cap for the eyepiece. You take that off, put them down over here, and you're set to go. You go to turn on the viewfinder, right here, you turn it on. You look through it, you see the red dot. You got to look directly down the barrel of the telescope to see that red dot, okay? If you're looking at an angle, it's not going to work as well. And once you've got that, you move the tube of the telescope to get it on what you want it to be, to get that red dot, let's say on the moon. It's very easy to do it. We'll move up and down, we'll move side to side. Okay, then you adjust the zoom eyepiece to make sure it's at 24 millimeters to start. And then you adjust the focuser so that you can look through it and actually it's clear to your eyes. Okay, you might have to go in, you might have to go out. It just depends on your eyes. And again, most people are going to be different. You adjust the zoom eyepiece. Let's say you want to zoom in a little bit more. Okay, once you've done that, you're going to have to adjust the focus. It's going to change the dynamics of the light coming through. And you adjust it to your eyepiece. So see, it's real quick, it's real easy. This would be great if we could now have you guys actually demonstrate it, go through it, maybe go outside, look at the moon and do this, but unfortunately we can't right now. Now looking through this telescope, here's some of the planets that you can see. So the top, it starts on the left, Mercury, Venus, and Mars. Now Mercury is hard to find, it's small. It's because it's close, it's much closer to the sun than we are, it's close to the sun. So it only comes up, you can only see it just after sunrise and just before dawn. And you're getting close to the sun when you're doing this, right? So you got to be careful. I can tell you Mercury is not very impressive. It's sort of a brownish dot is all. I've seen it once and I never bothered to look at it again. It just isn't that impressive. Venus, the next planet out from the sun, is very interesting. It can be, first of all, it's cloud covered. So there's a lot of light bouncing off of it. So it's usually the brightest object in the sky when it's up, the night sky. And so it can be very, very bright. And it also goes through phases, and you can see the phases very distinctly, just like the moon goes through phases. And Mercury does as well. Mercury goes through phases. Okay, so Venus is not all that interesting to see because you can't see any surface features other than it's a very white ball. But you see the phases, which can be very interesting. Venus is very easy to see when it's there, but again, it's closer to the sun than we are, so it's always not far from the sun from our point of view. Okay, then we have Mars. Mars, in a really good time to see it, when it's sort of at opposition, when it's as close to us as it gets, it can be very distinct. Other times it's pretty far away, it's sort of a reddish dot. But in the best of circumstances, it's really pretty impressive. You can see the polar ice cap rather, and it's very interesting to see, but not that often. I mean, if it's very far away, it's much less impressive and much smaller. Okay, the two on the bottom are the winners. These are totally awesome. Okay, you got Jupiter here and you got Saturn. Now these are all very good images of these things, and you'd have to see them in a fairly dark place to see them this well. In fact, these images here of Jupiter and Saturn are probably a little bigger than what you would see. It'd be smaller, but you can get Jupiter and Saturn to look very, very sharp in this telescope. Excuse me. You'll notice here, Jupiter, you can make out the bands of Jupiter. These are clouds in its upper atmosphere. And you see these 4 dots? Those are the Galilean moons. Galileo discovered those in 1610, and they circle around Jupiter. They were the first objects discovered that were not orbiting the sun, although people back then thought everything was orbiting the Earth. But these are the first things that anybody saw that wasn't orbiting anything in our solar system that wasn't orbiting the sun or the Earth. Saturn, you can see its rings. Again, these are under very good circumstances, which, by the way, is very hard to do on Long Island, especially in Nassau County, so close to New York City and all the lights. So you want to get to a dark place, and we'll talk about that next. So here's some stargazing tips. So you got to pick a good spot. It should be dark with few obstructions. So like, if you're going to do it next to a big building, well, that building is going to wipe out a good chunk of the sky. So the best place is like a big open field, which I know are not readily accessible on Long Island. Most places don't want you there after dark. The Robert Moses Park and Jones Beach Park, though they do allow you in there if you have a stargazer's permit, which costs $35 a year. But those are the best places to go where you can go legally. You can be there. If you're there and you don't have a stargazer's permit, you could get a ticket. More than likely, they just tell you to leave. But you could get a ticket. It's possible. But you don't need total view to everything. You need a decent view of the sky. If you're just like in my backyard, it used to be pretty good. The house would be in the way, but you'd get a pretty good view of going up. But then we decided that we were getting too much sun in the early evening, and we put a tree in, and the tree grew so big it's totally destroyed my view from my backyard. So I really can't do much in my backyard anymore. But you want to be a dark spot and with few obstructions. When you take the telescope out, it's not going to work very well, especially in the cold weather, for the first 10, 15 minutes or so. It needs to get to adjust the temperature of the telescope to the air around it. Of course, it just has currents, air moving around, and it just will not work as well. So you need about 10 to 15 minutes of that. And you want to take the cover off for those 10 or 15 minutes and let the cold air get in there. Telescope gets colder and you have better views. You got to let your eyes get dark adapted and stay dark adapted. The human eye is pretty amazing. After about 15 minutes in total darkness, your vision in the dark improves immensely. And it keeps getting better for the next 2 hours or so. It really is pretty incredible. But you can also mess it up really quick. You pull out your phone and you look at something on your phone, that light is going to mess up your dark adapted eyes. So the longer you're in darkness, the better you're going to see through the telescope. You're going to see more things. The one exception to light is red light. If you have a red light, that doesn't mess up your dark adaptability as much. So that's an option to have a red flashlight. Okay, some of the things to look at the sky: a planosphere, which I have a picture of that's coming up next, and is very good. It shows the constellations that are visible at the particular date that you're looking at them. There's also sky maps. Skymaps.com publishes a monthly sky map, which is specific to that month. Okay, it not only shows the constellations, it shows the position of the planets as well. Planosphere doesn't show the position of the planets because that varies throughout the year. It shows the constellations and main stars. Another good thing is a moon map to have, so you look at the moon, you can see what some of the things are that you're looking at. Another thing is looking at an astronomy magazine. Astronomy is a good one, and Sky and Telescope is another good one. They're both very good. Sky and Telescope is probably a little bit more geeky than astronomy, but they're both excellent. Okay, here's a planosphere. So a planosphere is basically two pieces of plastic. One has a view of the night sky, and then another one is affixed up on it, and it has like a clear window. So this is clear here, and you can turn it, and you can see here, you put your time to the date. So here we are in January, so let's say, we would move this, or this is set up for midnight in January, and it really just adjusts to what the sky looks at different times, okay? It's not as big as the sky map, which I'll show you in a second, but it gives you a good idea of what's out there. And, you have this, you can adjust it to every day, every hour, and you'll see it at different things. Now, it's set at 40 degrees north latitude, which isn't far from where we are, so it's pretty close. Okay, sky maps I mentioned before. So this is skymaps.com, and you go there at the beginning of every month. They'll have this sky map for the particular month. So this is January 2021. It's a 2-page thing. So this is a map of the sky, and this is the ecliptic, this dotted line. So this is the path that the sun takes across the sky. The planets orbiting the sun are on pretty much the same plane as each other. So they are all along the ecliptic. So when you look at the sky, this is the only place you're going to see planets. And it could be a little above, a little below, but this is where the planets will be. And this, as we move across the sky, as the Earth moves around the sun and we're seeing different parts of the sky, the ecliptic will change, it'll move. So having that for each month is a very good thing. And the only planet visible this month, visible well, is Mars. I think Jupiter and Saturn are very low at sundown, but Mars is right here, and that's pretty good. Now over here, it's got a list of the things you might see in the sky. Some of them are a little unusual and vague, like here on the 6th is the last quarter moon. First quarter moon is a really good time to look at the moon, so that's on the 20th. And the reason for that is it's up before sundown, and as it gets dark, it's still up in the sky. And right now, that's about 5:30 or so, right? But even in the summer, it's up. It's up before sundown, so you're getting a lot of it to see it at a good time. Reasonably convenient for people to look at. The last quarter moon is usually, late in the evening, like 11, 12 o'clock. Maybe it rises through sun and is gone by sunrise. Okay, the back of this, it has some interesting things to see that you can see with the naked eye, with binoculars, and with telescopes. So these are things to maybe look for that if you want to try and see. And over here, it just describes some astronomical events and some information. So again, this is available to you every month, free of charge, skymaps.com. They sell a whole bunch of things, but you don't have to buy anything. It's just go to this and you can get this very convenient sky map. Okay, here's that sky map, but blown up as big as I could make it and still get it on the screen. So right now, here's the ecliptic, right? Here's Mars. And this across here, this is the Milky Way. So this is where the Milky Way would be. You can't see the Milky Way real good from Nassau County. I've seen it from Robert Moses Park fairly well. Not great, but fairly well. It can be seen, but it's you know, if you're in someplace that's very dark, you see a heck of a lot more. So right now tonight, so here this is Pegasus, the flying horse. This is the Great Square of Pegasus. So this is the constellation, and this square, the Great Square of Pegasus, is an asterism, which is something smaller than a constellation, but something that people would recognize. Here's another example. Here's Orion. Okay, there's the belt of Orion is an asterism. There's 3 stars in a row. It'd be the belt of Orion. Up here is Canis Major, the Great Bear. And this is the Big Dipper. Here's the handle coming down, and here's the bowl. Okay, that's the asterism. Canis Major is the constellation. Okay. Yeah, I'm running a bit longer than I thought. Sorry about that. Here's some pictures of the moon. It's nice to have something of the moon when you're looking at it, so that you can see what what these things are, what things are called as you're looking at them. And see here, you can see like right here. This is the Apennine Mountains, and you can see the shadow cast by the mountains there. On a full moon, you wouldn't see that at all. You wouldn't even know that it's a mountain. It just looks all flat. And here again, this is the moon's on the other. The light is on the other side of the moon now, so you get a different shadows when it's in the third quarter, when it's waning. Then of course there's the full moon, where this is Tycho, which is a relatively recent crater on the moon. And by relatively recent, I mean within 10 million years or so. And these are the rays of materials that was thrown out when it crashed into it. And over time, that will all fade, okay? And, other places that has happened as well on the moon. Okay, here's some links. I'll try and put these in the chat section so that you can use that. Librarytelescope.org is a very good source for information about the Library Telescope, as well as just generally looking at the sky. Library Telescope Facebook page is, I take care of that myself. I post things on there at least a couple of times a week. The Library Telescope YouTube channel, this is the link to that, and then we have a lot of videos there about using the telescope. There's the skymaps.com. This is another good thing in Sky and Telescope on their website. Again, and this is free. There's an observing section where they'll show you the week's sky at a glance. So it'll go through verbally, tell you, and with charts, tell you what there is to see in the sky. And here are 2 astronomy clubs: the Amateur Observer Society of New York, AOSNY.org. I am a member of that club. Here's another one, the Astronomical Society of Long Island, astleyclub.org. AOS is mostly in Nassau County, and Astley, they meet the Vanderbilt Planetarium. So they're kind of more of a Suffolk County club, but you could belong to both of them. I know a lot of people who do. And usually it's fairly cheap, and you'll find a lot of people who help you use the telescope. Okay, boy, I went a lot longer than I thought I would. Sorry about that. But if anybody has any questions.
Can you go over the viewfinder one more time?
Sure.
Like, I don't get how you turn it on. And how about if it's out of alignment? How would you know that?
Okay, so let me start with, you turn it on, see this, these two dots, these two white dots?
Right.
So they're lined up, that means it's off. This is a knob here, a dial, a circle, a wheel that you can turn, and that turns it
Okay.
on. So
Okay.
it's a very distinct click when you turn it on,
Okay.
okay? So you've turned it on, you should see the red dot. If you don't see the red dot, as you look through it, like you're at the back of the barrel looking into it, like see the head here looking into it. If you're not lined up right, it's going to be too far to one side or the other side. You're not going to see it. So you got to move around, move your head around. Make sure you're lined up right behind it, looking straight through it, like this picture is here. Okay, so that should be on what you're looking for. Now, let's say it's the moon. You put that on the moon. You go, you look through the eyepiece. You don't see the moon. Okay, because it's out of alignment. So it's probably fairly close. Aligning it is a process that isn't very hard, but most people don't do it. If it's out of alignment, it's probably only out by a little bit. So you can move the tube around a little bit to see if you can find it. Okay. But if you want to align it, you're better off doing that in the daytime. And take it outside, set it up, and look at something that's at least 100 yards away. Maybe it's a chimney on a nearby house or something like that.
Mm-hmm.
And you point the telescope at that, and you look through it. Okay, now you're on it. You look through the eyepiece, it's not there. So now you move it, you get it so the telescope is on that chimney, let's say, right? And then you go in, you look through, and you see where the red dot is. Now this this wheel right here, that moves the alignment up and down. This one
Okay.
right here moves it left and right.
Okay.
Okay. I mean, I wish nobody ever has to do this, because if you keep doing it, you get it so far off that it's really hard for somebody to try and fix it. I mean, it takes me 5 minutes to fix it, so it's not a big deal, but I got to get to the library and do it. That librarytelescope.org, there are videos that explain how to do it on there.
Is the library, when the telescope's returned from somebody, are they going to make sure it's aligned before they hand it out again? Or that's going to be up to us?
It would vary. If I'm around, I always check it. If I come by the library and it's there, I always check it.
Okay.
If nobody messes with those two wheels, it's not going to go out of alignment. I mean, unless you bang
Right.
it. So it
You
should.
know, I believe Tom's going to come by periodically and look at them and check the alignment and all if he can, you know. So,
Is this going to be permanently at the library, the telescope?
well, I can explain that part. So,
Oh, okay.
okay, so I'm with the library, and Tom was nice enough to work with me and the library on it. So basically, what it is we're lending it out to people for a 7-day loan period, and we have one at each branch of the library, and Tom made all those modifications that he was showing you, so they're both exactly the same. So the procedure that he showed you today, like, will work for both of those. But we're lending it out for 7 days to people, and we're quarantining it for a few days when it comes back because of the whole thing with COVID. So basically right now there's a waiting list for both of them, but that's a good thing and a bad thing. You know what I mean? So you'd be a few people down on the waiting list if you signed up for it. And
I know. I have 15 people in front of me.
oh my God. It might not be quite that bad. It might be more like 10 or 8 or something like that, because basically they're treating Central Avenue and Bar Harbor like they're different libraries now.
Oh.
So so you might only have like 7 people in front of you if you reserve it from Bar Harbor. So,
Okay.
I can check to see where you are if you have any questions about it. But basically though, yeah, it's a nice thing. And we're so glad to be able to offer it as a program, and we're so glad that Tom, that Tom sold us on it, because he's a good salesman for the program.
Well, I've only got 9 libraries, so I'm not that good, but
well, a pretty good salesman. It's hard to sell libraries on things.
that's true.
The other thing is, I tried to make it easy for people to sign up to use it. like, I don't know if you can come out of the slideshow for a second, Tom, because I might just show people something really quick. Like, if you can. I mean, to stop sharing for 1 second, I'm just going to bring something up quick. I'm going to hit share screen on mine. And that's not what I wanted to share, but you know what? Give me 1 second here. We'll get this. Okay. Okay. So this is the library's website. So what I did, right, is I added something down here. There's a button down here that looks like a telescope that you'll
Oh.
see in you, and you hover over it, and the button gets big. Okay. You click on that, and we have the fantastic page on our library about the library telescope program. And it gives you like what our policy is. And if you want to reserve it, you can easily go to where it says reserve a telescope now. Now, you know, like we were saying before, there is a waiting thing. I'm going to get out of this. So if you want to share your thing again, Tom, it's good. Or you can call us up and ask to reserve it. I mean, that's the other option. I'm going to hit stop share. There you go.
When COVID is over, will the library do like in-person things?
Yeah, we're going to go back to that eventually. I mean, I'm not, you know, I'm not in charge. I mean, I work here, but I assume when COVID is over that we're going to go back to doing like in library things.
And Tom could come in and give like demonstrations to us as a group?
Yeah, at that point, like when the library, the management of the library decides it's time, we could go back to that.
Okay.
Tom has told me he's done a lot of presentations like that in the past. He's done, he's gone outside with people with his own telescope and done a demonstration. So yeah, I mean that would be really nice, and we all look forward to that day. It may be a while off. I mean, I don't know.
Okay.
Know exactly when that's coming.
Tom, what is the cost of a telescope like this?
The telescope, it's about $200. It's gone up lately for some, well, they tell me that it's gone up because of demand and people can't go anywhere out of their house, right? So people are buying telescopes. So I think it's gone up to about $220, but I still see it for about $200. The Zoom Eyepiece is used to be about $70, $75. It's up to like $90 now. But I think that's going to go down as well.
So this would be a good intermediate and beginner's telescope?
It's a beginner's telescope.
Okay.
As telescopes go, it's not all that impressive. I mean, the good thing about it is its portability and its sturdybility. I mean, it's very sturdy. I mean, of course, if you drop it, you can break it, but
Oh, heaven forbid that happens.
and it really works, pretty well. It's a really good first telescope. And it's perfect for the library telescope program. I mean, you take it out once, you'll probably want to take it out a few times to get, to use it as much, to really get the use out of it that you can. But it's a very nice telescope, perfect for this purpose, because a lot of, bigger telescope, like a 6-inch or an 8-inch reflector is very, it can get very cumbersome. They can get heavy. Like my telescope, a 12-inch is gosh, what is it? It's 100 pounds in total. The tube weighs 150 pounds, and the base weighs 50 pounds. So it's a bear to get around. Now, if you were looking at a telescope, you wanted to buy a telescope, and you get more bang for your buck with a reflector with a Dobsonian mount. That's what this is, as opposed to a tripod. A more expensive telescope with a really good tripod is great because you can break it down. Each piece is not that heavy. But an inexpensive telescope with a cheap tripod is like the worst thing in the world. It just is wobbly. And those are telescopes that aren't even worth buying. I mean, they're just junk because it wobbles too much. You can't really see anything, which is why especially for low cost. I mean, when you get into very expensive telescopes, they make fantastic tripods that are very sturdy. When you're in the thousands of dollars at that point. But these, with hundreds of dollars with a Dobsonian mount is very, very sturdy. which is
And
what.
so you can be contacted if we get the telescope via the library or via the webpage. I didn't mean to interrupt you there, sorry.
Okay. I don't know if you put my email address in there, Lee. There's a little document that goes with it talks about how to use it a little bit. Many of the things that we've talked about here, or some of them, and then also what you can look at in the sky. I don't know if we put my email address in there. I don't want to give you my phone number because I really don't want to get a
Of
phone
course
call.
not. Of course, yeah.
Like I'm having trouble seeing the Orion Nebula. By email, I'm readily available.
Thank you so much for the presentation, and thank you,
No,
Lee.
it's my pleasure.
Yes, thank you very
For
much.
doing this. I mean, I think this is such a great program. It is just, every library should have these. And I've been trying real hard to get every library in Nassau County. I've only got 9 out of the 54, I think there are. But I'm going to keep trying, and we'll see where we get.
Will we be able to reserve it for a specific date in advance? Like if I wanted it for something in June, or does it, availability is as it rolls through the list?
The library will be closing in 10 minutes. The computer room is.
I think Lee'd have to answer that one.
Yeah, I'm sorry. We were just making closing announcements at the library. Okay, so the way that our reservation system is working right now is basically there's a line of people that are reserving it. So it's not really for a specific. It's more like like if you're a third in line for it, you'll get it like after the 2 people in front of you get it.
Right.
So there's no reserving a specific time slot, which
Okay.
I think people would enjoy being able to reserve a specific time slot because certain astronomical events happen at certain specific times. But yeah, the way that we have it right now, it's just sort of like there's a line of people waiting for it, and when it's your turn, you get it, which could be a few weeks down the line, So perhaps we could change it in the future, but everything is subject to to availability. So you could want a specific week, like even if we change the reservation system to be more in line to work that way, you could want a specific week, but somebody else could want it too, and they could get that before you did.
Exactly.
So,
right.
there's there's pluses and minuses to everything. But any
Gotta
kind
see
of
how.
you have about the program locally, you can ask me about it, and I can try to see if I can help improve things.
Okay.
We were talking earlier about maybe getting more scopes, which once again, like not completely up to me, but I can suggest it and see if we can implement that. So. Any other questions?
No, not for me.
I just want to say thank you.
Thank you very much, Tom.
Yeah, thank you very much.
Thank you.
It was very good, and thanks for making this available. It's awesome.
You know what? It's nice. It's just a nice thing, and thanks a lot again, Tom. I mean, we really appreciate it, and
Pleasure.
we're loving it. So, yeah. Thanks again.
Okay, gaze on.
Thank you.
Take care, everybody. Thanks for coming.
Thanks, Tom. Thanks, Lee.